Yes, hi student. In this video lecture, we are going to discussing one more concept of computer graphics, that is the hypercurve. So, when we considering this hypercurve curve is also called as the piano curve. It is very easy to implement. So, when we considering this curve begins with initial square and the generation of the curve requires successive approximation. So, in this curve, we considering the three different approximation. So, each and every approximation consider with this example, right? So, considering first approximation, in this first approximation, we dividing the square into four quadrant and then drawing drawing the curve which connects the center point of each quadrant. That means first and connect center point of quadrant. Here we considering this curve, this square, and here we divide this square into four different quadrant like this one, and here we considering this as the center for this quadrant, and we just connect this quadrant like this one. Next, second approximation. In second approximation, we will further subdivide each four quadrant and draw the curve, and also which connect the center. Connect the center. So, and the center point of each of these final subdivision before moving the next major quadrant. So same way here we considering, this is our figuring, consider first approximation, second, here we considering again this four quadrant into four different part, and we connect the center. So these are the different center, right, like this one. So again we connect the center like this one, like this one, right. This is second approximation. In third approximation, again subdivide each quadrant into different four coordinate and process continues. So here we considering like this one. Here this is our four quadrant like this one. Again this four quadrant is divided into four different parts like this one. So this is the way for dividing, and we find the center of this quadrant. So these are the center like this one, and then we are going to connect this center like this one. So this is the way, sorry. So by using this way, you correct this, right? So by using this way, we can, looking at the careful, we will come to know that the curve is not getting overlapped at any point. So when we considering this one, we considering the some point, curve is arbitrarily close to point, to every point in the sequence. There is the no limit for subdivision, and we feel the sequence. Ideally, when we considering the length, this length is infinite for this curve, right? So each subdivision the length increases by factor 4, right? Because we distribute the curve into, sorry, we distribute the square into 4 different quadrants, since the curves is equivalent to line only. And when that means, when we considering this curve is equivalent to line only, right? So it's a topological dimension d1, that means topological dimension dt must be equal to 1. So so when we considering this curve, we having some general expression like this one. At each subdivision, that is at each subdivision, scale changes by 2, that is every approximation we dividing the plane into 4 quadrant, right? But the length of the changes by the length of the center we changes the 4, right? So at the subdivision, so we need 4 scaled curve to form original curve, right? That is n is equal to s raised to df, that is n is equal to 4, and s is equal to df, that is df is equal to 2. So the Hilbert curve has topological dimension, that is the dt is equal to 1, and fractal dimension df is equal to 2. So when we considering these diagrams, due to this factorial dimension 2, it can be looks like a 2D object, right? So this is all about the Hilbert curve. Thank you.